Okay, guys, so if you remember last class, we were like introducing research methods. We were looking at the fact that every experiment or every bit of experimental research has certain variables. Yeah, we looked at this variable of the IV, we looked at the variable of the DV, we looked at the fact that one of them usually causes or produces the change in the other variable. Okay, so we say that in order for an experiment to have a cause-effect relationship, an experiment must be investigating a clear independent variable and a clear dependent variable. And in any research scenario that you're going to get, you will be able to identify what is the IV and what is the DV. What is the thing that's causing the change? That is the IV. And what is the behavior or what is the phenomena that we're measuring for change? And that's the DV. Okay, so we are going to look at a research scenario as well in the worksheets that we'll be looking at today. But last class, you would remember that we did a few examples talking about how an IV can influence a DV. For example, how green tea can influence weight loss, how energy drinks can influence athletic performance. And we talked about this idea that although in most cases, the IV is the main thing that causes the change in the DV, that's not always the case. For example, although in an ideal world, we want, for example, we want the sports drink to be the main reason for the person's athletic performance, there are also other factors that can influence that, okay, other than the sports drink, okay, other than the IV, there are other factors that can kind of sneak into our experiment that can actually influence the end result of our experiment. And that can make it difficult for us to determine, okay, was it that athletic performance was influenced by sports drink consumption, or was it more so influenced by something else, like maybe the participants, exposure to training outside of school hours, the participants' diet, the participants' weight. All of these things can have an influence on things like stamina, endurance, and all that kind of stuff. So we're looking at this idea today that other than the IV, there are other variables that can influence our DV. Because these other variables make it difficult for us to determine, was it the IV that actually caused the change in results, or was it some other factor? These are actually known as unwanted variables. These are variables we don't want in our study. Okay, the last thing we want is to run a huge study on the effect of sports drink consumption on athletic performance. And then at the end of the study, look at our results and be like, okay, we've got our results, but how do we know that this guy's stamina and endurance wasn't because he attends training 3 times a week, whereas this other guy doesn't? Okay, and then these unwanted variables can actually affect the DV in an unwanted way. Unwanted meaning that it's hard for us to really isolate whether the IV was the one that had the effect or whether it was the other outside factor. Okay, so unwanted variables can be of 2 types. They can be extraneous variables, which are just like a general outside factor, which often can be controlled for. For example, if I'm the experimenter and I'm getting the participants to maybe run around a sports court to test their athletic performance, what could be some extraneous or outside factors that could influence how well they perform on the day? Just write it in the chat box if you can think of any. What are some external or outside factors that could influence a person's ability? The weather, excellent. Okay, the weather is definitely a factor. If it's raining and it's pouring and it's windy, I can see that straight away outside. Yeah, and I can be like, okay, maybe we don't want to run the experiment tomorrow. Look, after tomorrow is 20 degrees, looks sunny, let's run it then, because then the results are more likely to be very reliable, and there's not going to be any effect of those unwanted variables there. Okay, so light, noise, temperature, weather, climate, setting, all of these things can act as extraneous environmental variables that are unwanted. Okay, if we do another experiment and we look at, okay, the effect of what time you do a SAC on actual SAC scores. Okay, first of all, before we get into the unwanted variables of a study like this, if I'm doing an experiment and investigating the effect of what time we do a SAC on an actual SAC score, so maybe comparing doing a SAC in period 1 compared to doing it in period 6, and that's my study, and then I'm going to get students to do the SAC and then look at how well they did or how well they didn't do. What's the IV and DV in an experiment like this, guys? Just put it in the chat box. What would be the IV if we're looking at the effect of the timing of a SAC on an actual SAC score or a SAC percentage there? Yeah, the timing of the SAC would be the IV. That's what we're varying or manipulating in this scenario. That's correct. And then what would be the DV? And the DV would be the actual SAC result that you get. That might be the actual percentage score that you get. And that's something that is clearly going to be the DV because that's something that we can measure for change. Okay. What time we do the SAC is the IV because that's a thing that we can manipulate. That's a condition that we can change. So I might get, for example, our class to do the SAC in period 1 and then get another year 10 class to do their SAC in period 6 and then determine, okay, what are the different changes? Or if we want to make it more consistent, I might get the same group of students. I might get you guys to do a SAC in period 1 and then do another chapter SAC in period 6 and then basically see the difference in that same group of students when they do a SAC in period 1 versus period 6. Okay, so that's the IV and that's the DV. In an experiment like this, we really want to make sure that it's only the timing of the SAC that has an influence on SAC scores. However, realistically, we know that there are other factors that can influence someone's SAC score. So let's brainstorm, guys, some of the other unwanted variables, which in this case are not the IV, any factors that you think can influence a person's SAC score other than the time that they do the SAC. So just let me know, just jot down or list down any factors there that you think can influence the DV, in this case, influence a person's SAC score other than the time they do the SAC. So just put your answers in the chat box there. Yep, the amount of time they study. Excellent. I need more answers from more people. It's the same people that are giving me answers every time. Come on, guys. I need more answers. It's just, this is not a technical question. It's just a general knowledge question here. We're just brainstorming. So what are other factors other than the time you do a SAC that can influence your actual SAC score? So the amount of time you spend studying for a SAC can obviously influence your SAC score. It's not just about whether you do it in period 1 or period 6, but that's another factor, yeah? These are all unwanted variables. So I need some more factors now. Other than the IV. So what can we say? The amount of sleep you got, excellent. Okay, so whoops. So the previous night before the SAC, how much sleep did you get? That can influence your SAC performance or your test performance as well. What else can we talk about? Previous events, yeah, whether they were negative or positive. So for example, if you got some really bad news on the morning of your test about, you know, someone in the family's, you know, really ill, or you didn't like, let's say you're not going to receive a really important parcel on time or something like that. I don't know. You can talk about this. You can talk about maybe past stressful events that occur close to the test. Okay, that can really kind of interrupt your peace of mind and your state of mind there, and that can stop you from doing as well on the test as you would have hoped. So that's also another unwanted factor. And there are so many other unwanted factors that we can talk about. Okay, but all of these you can see, guys, are just factors that are not the IV. They're not relating to the time you do the SAC, but they're other factors other than the IV, which can just as equally have an effect on the DV. That means just as equally affect our results. Because remember, DV is another word for results. Okay, so when we're looking at an experimental scenario, we always want the IV to clearly affect the DV in a very like just one arrow going to another arrow kind of clear observable effect. But this doesn't always happen in real life. In real life, what happens is that you've got all these kind of unwanted variables kind of sneaking in between and like, nope, I'm going to affect the results now. So if a person does a SAC in period 1 and doesn't do well, I can't really say with confidence that this person didn't do well because they did the SAC in period 1, because maybe it was that they had experienced a really stressful event the day before. Maybe they'd pulled an all-nighter the night before and didn't get enough sleep and couldn't concentrate. Maybe it was because they didn't bother studying for the SAC in the first place. So how do I now know that it was the IV that actually caused the change in the DV or whether it was another factor? Okay. This is why these are called unwanted variables. They make it difficult for us to determine the actual effect of the IV. They're these sneaky little variables that come in between and make it difficult for us to say that, yes, the IV did cause a change in the DV. Okay, so that's basically the idea. If you really understand this topic is probably not that difficult, but it's actually one of the most difficult topics in research methods for most students, okay, especially in BCE. But if you can just understand this basic idea that an unwanted variable is a factor other than the IV that can lead to a change in the DV, and it's something we don't want because it makes us less confident in how our results changed, then that's basically all you really need to know. Okay, that's the basic idea. Okay, now there are two types of unwanted variables, but they're basically more or less have the same effect. An extraneous variable is more of an outside environmental variable. Okay, and usually these are quite obvious and can be controlled. For example, me taking my group of participants to, a sports court and realizing it's raining, realizing that half of them are not going to be able to run as properly as they usually do on such a wet surface there. So I decide to postpone my experiment to another day. That's an obvious one, okay? That's an environmental variable. So that can obviously usually be identified and controlled in time. The unobvious ones, or we would say the more sneakier ones, are the ones that kind of slip through and are not controlled for early on in the study. So these are things like individual participant differences, things that we listed in this space before, like amount of sleep that a student got, amount of time that they spent studying. Those are not things that I can straight away tell just by looking at a student. Okay, so those are the more hidden variables. Those are the more sneakier ones, and they often are not identified and not controlled for in time. As a result of that, they kind of slip through and go on to affect the DV in an unwanted way. And that's what the word confound means. When we say confound, we're saying that something is affecting the DV in an unwanted way. And obviously, whatever confounds the DV, it's not the IV, it's something other than the IV. Okay, so that's the basic idea of unwanted variables. All right, now we are going to look at another example here. This is the example from the slide, but I just thought I'd show you those extra examples just to really understand what it's about. Okay, now this basically repeats everything that I kind of already talked about, just with another example. So let's say we were doing a study or an experiment on the effect of poor sleep on driving ability. So in this case, guys, can anyone tell me what's going to be the IV and what's going to be the DV in this study? And we'll just put a little arrow matching them up to the sentence there. What's going to be the IV in a study that's trying to investigate the effect of poor sleep on driving ability? Yeah, the amount of sleep or the quality of sleep. So whether someone got poor sleep or good quality sleep. That's the IV. The DV is the behavior or the ability or the skill or the phenomena that we're measuring for change. So obviously the DV is going to be the driving ability. We can measure driving ability in so many different ways, or we can operationalize the variable of driving ability in many different ways. For example, how many cones a person hits as they drive through a driving obstacle course. How fast does a person kind of react as they drive on the road to like different speed conditions or different hazards that come onto the road, all that kind of stuff. Okay, so that's basically what the IV and DV will be. Now, if the IV is poor sleep, in this case, in this experiment, what we would want is for the IV to cause the change in the DV. Okay, but we know realistically that there are other factors other than the IV, that is other than poor sleep, that can cause a change in driving ability. Yeah. So can we brainstorm, guys, together now? There are a few on the slide itself, but just brainstorm. It doesn't matter if it's the same one as the one on the slide. Brainstorm some other factors now. What are some other factors other than the level of sleep that you've got that can affect your driving ability? Just list them down in the chat box and I'll just jot them somewhere here. Just jot them down here. So what are some other unwanted variables there, or unwanted factors? Could be an extraneous one, could be potential confounding. Yeah, whether a person has a disability, correct. We know that people with certain disabilities or medical conditions can't really drive as well, or they have joint pains that stop them from driving as quickly. The amount of cars on the road. You could even say traffic conditions. Okay, people generally tend to drive worse in high traffic conditions compared to whether a person is intoxicated. or sober. That's right. A person's age, okay, we know that a person who's 18 years old, who's only just got their Ps, they're probably not going to drive as well as someone who's been driving for maybe 25 or 30 years. So your age, okay, or the number of years you've had a license can also play an effect there. We can also talk about whether you're under the influence of drugs. So have you used any sort of drugs? So similar to whether you're intoxicated through alcohol, drug use can also be an effect, as well as weather conditions. That can also influence your ability to drive well. We can even talk about distractions in the car. Okay, so a lot of people tend to drive better alone compared to, compared to when they're with someone. So that can actually influence it as well. Okay, so those are some really good factors. Yeah, awesome. So those are some unwanted variables. So basically, if we ever give you a research scenario and ask you to brainstorm or ask you to identify an extraneous or potential confounding variable, all you need to do is think about what is the IV, and then think about all the other factors other than the IV that can still influence that DV or that behavior that we're measuring. In this case, that can still influence a person's driving ability. So yeah, these are some really good tips, and we can see that these can influence a person's driving ability and make it difficult for us to now determine, was it a person's poor sleep that affected their driving ability? Or, if a person in my study, if I was driving them through one of those like driving courses with the orange cones and stuff, and they hit like half of the orange cones and they're like driving everywhere, can I now conclude that that was because they didn't have a good amount of sleep? Or can I conclude that it's because they've just got their license like a few weeks ago? Can I conclude that maybe they're drunk? Maybe they had a lot to drink at the bar the night before? Okay, can I conclude that maybe it's because they're not in a good mood? Maybe they're just not motivated to drive. Can I conclude that because maybe it's because of the weather? Maybe it's very dark or gloomy outside. Maybe it's been really rainy and they haven't been able to brake in time, or they've pressed the brake in time, but then the car hasn't really come to a stop in time compared to when it hasn't been raining. Okay, so many factors there that we can talk about that show us how the eventual results or how the eventual DV can be influenced by another unwanted factor other than the IV. Okay, if you like, if you're interested in another example, there's one here in the image as well. Okay, we're looking at this idea. If we were doing another study talking about, for example, the impact of coffee drinking on heart disease. Okay, we know that generally when people drink too much caffeine, it can lead to heart conditions or worsened heart conditions in people who have those issues. So when we're looking at the effect of coffee drinking on heart disease, okay, and heart disease is kind of the variable that we're measuring for change to see how much the heart gets impacted as a result of coffee drinking. We know that there are other factors other than coffee drinking, other than the IV, that can influence someone's ability or someone's tendency to get heart disease. For example, if you smoke cigarettes, if you drink a lot of alcohol, if you have a genetic predisposition to developing heart disease because it runs in your family, the level of exercise you have, your overall diet, whether you consume a lot of saturated fats and foods that are high in cholesterol. All of those factors can be confounding variables or unwanted variables other than the IV, other than coffee drinking, that can still have an effect on the DV. Okay, so just another example for you there. Okay, so that's basically what we're talking about when we're talking about extraneous and potential confounding variables. And we've got a few more questions similar to this in your worksheet as well. Okay, I'm going to give you guys one more example. I'm just going to jot it down here. And I want you to just give me one last brainstorm of what are the factors, what are the unwanted factors or unwanted variables that could influence the DV in this example. So just give me 1 second. I'll give you a scenario. So we'll say an experiment is attempting to investigate the effect of, let's see. The effect of maybe stress, the effect of stress on ability to okay. All right, I'm trying to make this one hopefully that should be straightforward or clear enough to visualize. Okay, so this is the experiment. The experiment is investigating the effect of stress on a person's ability to complete a series of mathematical problems. Okay, so now before we look at what the unwanted variables are, can anyone in the chat box tell me what would be the IV, or in other words, the cause variable, and what would be the DV, or in other words, the effect variable in a study like this, or in this particular scenario? And then we'll jot these down, and then we can easily figure out what the unwanted variables are. So what do we think? Yeah, excellent. Stress is the IV, because that's what we're manipulating or we're trying to change. And the DV is the particular behavior or the skill that we're measuring for change. In this case, it's a person's ability to complete the maths problems. Yeah. Okay, so this is the IV and this is the DV. I'll just get rid of these words so it's a bit clearer. Okay, so that's the IV and the DV now. So if we do our little arrow thing and we have a look at that now, we'll go IV and DV. In a perfect world where all experiments go according to plan and there are no unwanted variables, essentially our IV of stress should be causing a change in the person's ability to solve the maths problems. But now we're trying to brainstorm what are the sneaky little variables that come in between that say, you know what, we're not going to allow this to happen. We're not going to allow you to confidently make this prediction that it was stress that led to the change in a person's ability to solve maths problems. So now that we know what the DV is, we know that the DV is a person's ability to complete maths problems, and we know that the IV is stress. What are factors other than the IV or other than stress that can influence a person's ability to complete a maths problem? So let's just brainstorm them in the chat box and yeah, let me know. Okay, we've got one. So their ability to solve maths problems, correct. Okay, mathematical ability, or your ability to solve a maths problem can actually influence, can act as an unwanted variable. So let me just open up another little box here. So unwanted variables, okay, include mathematical ability to actually solve the maths problem. Okay, sometimes you hear students saying things like, oh, I'm not really a maths person. I don't really like maths. I don't feel like it doesn't work when I try to do it, and that kind of stuff. And, sometimes, yeah, some students are a little bit more, they do enjoy maths a little more, and they might hone in on that ability a little more than others. Knowledge of the topic, yep. We all know that we can't do a test properly if we haven't studied the basic content of that particular thing. So if you don't have the knowledge of the particular formulas required to solve the maths problem, you might not be able to do it. Yep, disruptions due to noise, correct. So if they're solving a maths problem, but it's in a noisy classroom, or the classroom next door is very noisy, it might affect your concentration. Yep, that is another factor. Unwanted distractions. So yeah, other distractions around them. For example, maybe people wanting to talk to them, or maybe the fact that there's a lot of construction happening outside, or that the lights in the corner of the room are flickering. Any kind of other distraction there. Yeah, the time given for the test is another good one. Time given for, sorry, not the test, time given for the student to solve the maths problem. Yep, the person's surroundings. That's another good one. So example, whether you are in your normal class or usual class with people you know versus people you don't. Okay, you might not feel comfortable in a class where you don't know anyone and you're the only one there. That's kind of like an outsider. Okay. What's one other factor we can talk about, guys? Just maybe one or two more. Yep, whether they've practiced the problems. Practiced similar problems before. We know that when you guys do practice questions before the test and you get a similar one on the test, you generally tend to do better because you've had previous exposure, okay, to that particular problem. And yeah, we can even bring up mental state, maybe not so much talking about how stressed the person is, because that's our IV, but maybe talking about whether the person has other mental health issues. For example, whether the person has something like depression, which might lower their motivation to actually, do well on the test or to actually even bother. Okay, generally people with other mental disorders like depression or bipolar, they have very low motivation. They don't see the point of it. They don't see the point of or the purpose of doing things or putting effort into particular things there. So that's a good one. And whether they understood the teacher and were able to ask questions. Yeah, that's a good one as well. So whether the student had an opportunity to ask any questions or whether they were kind of left on their own. So many unwanted variables here, all of which can actually overtake or we could say even trump the effect of the DV. Okay, in other words, the effect of the IV. In other words, these unwanted variables can overtake the effect of the IV and make it difficult for us to determine, okay, this student got, sorry, let me go back here to draw. Okay, so if I was to say, for example, this student got 82% on the maths problem, on the series of maths problems, was this a high score because of the fact that they were under less stress, or was it due to the fact that they were, for example, maybe very knowledgeable in the topic, maybe very motivated and maths is their favorite subject, maybe were in a room where there wasn't any noise, maybe had more time to do the maths problem compared to some other students, okay, maybe have done similar problems before with their teacher or with their tutor, okay? So there are so many other factors other than the IV in this case, which could explain that high score or high confidence or high proficiency in being able to solve that maths problem. Okay, so these are the kinds of application type questions, guys, that we need to be familiar with. If you found it easy to brainstorm unwanted variables to this kind of a scenario, this is literally the same kind of skill you get tested on in year 11 psych and year 12 psych. In fact, in the psych exam on Monday, there was a literal question that gave them a scenario and just said, identify and explain an extraneous variable that could have affected the result. So it's kind of like the same skill you're using here, but you're just going to be continuing to use that, especially if you decide to do VCE Psych next year or the year after. Okay, so really important for us to practice these skills. Okay, cool. Now we're looking at sampling. Now this is a pretty straightforward topic compared to the previous one. Sampling is just about how we select participants, okay? Basically, sampling procedure, if you ever see the word sampling procedure, it just basically means a procedure or a way in which we select participants for our study. Okay, for example, if I want to do a study if I want to do a study in year 10 students, or I want to examine the effect of, I don't know, green tea consumption on SAC performance or test performance in year 10 students, the easiest kind of group of students to pick is you guys, because you guys are my class. I see you guys multiple times a week, and it's easier for me to choose you guys as compared to going out of school and choosing another bunch of year 10 students, or as compared to going to another year 10 teacher's class and asking for their students. Okay, so that's kind of what convenience sampling is. When we think about the word convenience, can anyone just put in the chat box a few words that are similar to the word convenience? When something is convenient for you, or when something is of convenience to you, what does that actually mean? It means that it's efficient, correct? It means that it's within reach, okay? All of these are basically kind of synonyms for within reach, easy, okay? That's what convenience is. It's suitable for you as well, yeah. So all of these kind of synonyms basically explain what convenience sampling is, that it's a type of way in which we select participants, where we select participants looking at our best interests. Our best interest means looking at what's easiest for us to do. So you can see that usually this involves choosing participants that are within your reach or who are close by to you. So we can see in this picture here, for example, this is the experimenter, and he's wanting to choose these participants who are closest to him. So that might become his sample, because it's easiest for him to grab these participants compared to participants who are further away. Okay. So that's what convenience sampling is. It's basically choosing participants for an experiment based on how easy they are to access for you, or in terms of how close they are to the researcher. Okay. Now, some examples of how this might look like in a scenario is, for example, a teacher asking her students to take part in the experiment she's doing, or a university lecturer asking his students if they can sign up to a study that he's recently started to do. Okay, so just anywhere where you can see that it's really easy for a person to be chosen based on their relationship to that experimenter is going to be convenient sampling. In fact, convenient sampling is the main one that we are looking at this year. Also, another clue for you to know that convenient sampling is used is whenever you see the word volunteered, it means that convenient sampling was used, okay? Convenient sampling is easy and good, and it's got all these benefits, but it's got one major problem, and that's that you can't generalize the results back to the population, okay? That's because the people that you chose to be in your study are generally kind of what we call as a biased sample, okay? It's not like we gave everyone a chance to take part. For example, these people were not even considered in the sample or in the participant group for the experimenter. He just chose the people that were closest to him. And so that often leads to a biased sample where not everyone gets a chance to be considered to be a part of the study, okay? So that is one of the main issues with convenient sampling. It leads to a biased sample rather than a representative sample, okay? So that's convenient sampling. Then we've got the 3 types of research designs. So the 3 types of research designs are just talking about how we would allocate participants once they're in the study. So once we've selected them through convenient sampling, we would then decide, okay, which group am I going to put this bunch of participants in and which group am I going to put the other group of participants in? So for example, in our class, I think we've got let's say we've got 24 students. I would put 12 of those students in one experimental group and the other 12 in the control group, okay? If I'm using that kind of a method, that's called independent groups design. That basically means that I just randomly allocate half of the class to the experimental group and half of the class to the control group. What does randomly mean? It means that I maybe put all 24 of your names in a little box. The first 12 that I take out and read, those are the people that are going to be in the experimental group. The remainder will be put in the control group. Remembering that if this is the experimental group and this is the control group, okay, if condition A is the experimental, condition B is the control, these are the guys that are going to be exposed to the IV, and the control group is just there for the basis of comparison. So they're not going to be exposed to the IV. Okay, that's the main difference between those 2 groups there. Okay, the advantage of independent groups design is that you can organize this quite quickly. So the chances of participants dropping out or withdrawing is quite low. It's not a time-consuming process. It's just a simple matter of dividing the participants out. A disadvantage, however, is that because each of these participants is a different person, just like each one of you is a different person in class, would lead to a lot of individual participant differences, like differences in diet, differences in sleep, differences in ability in the subject, and all of those variables, depending on what you're studying, could actually have an influence on the final results. Okay, so that can be and what does this equal, not equal sign means? It just means that the participants in one group, in an independent groups design, are not the same or not equal to the participants in the second group or the control group, okay? And that's why we call it an independent groups design. One group is completely different and independent from the other. It's not like we're recycling the same participants twice, okay? However, this idea of recycling participants comes up in repeated measures designs. Repeated measures designs is kind of what its name suggests. It's when we take the participants, let's say 24 of you guys, and we make each one of you go through the experimental condition and then the control condition, experimental condition, and then the control condition. Okay, so you can see participant A here is the same guy as participant A in condition B. It's because we are literally just recycling or reusing the same participant for both conditions there. So this means that we need less participants. Rather than having 24 of you, I might just choose 12 of you. Okay, so I don't need as many participants to take part. That's an advantage, because obviously then I have less individual participant differences there. However, the disadvantage is that you can have order effects. Order effects means that because these participants are going through one condition and then the other, they start to get tired, they start to get drained and exhausted, and then they might start not putting as much effort into the study or into the experimental task that they're doing. Okay, so repeated measures design is when the one participant is exposed to both the experimental condition and the control condition as well. Okay, so they become a member of essentially both the experimental group and the control group, which is the complete opposite of the previous design we looked at, where each participant was different. Okay, in this case, they're equal because they are the same participant in both conditions or across both conditions. Okay, and the last one that we're looking at for today is the matched participants design, or the last type of design. A matched participants design is not using the same participant, but it's basically using getting one participant and then trying to find a matched pair for them. So finding one participant who, for example, maybe has an IQ of, let's say, 120, if that's what we're measuring for change, okay? And then we're basically finding someone else who's got a similar IQ, maybe 118. So basically, they're not the same person, but they're very similar in terms of their characteristics. And because they're similar, we can actually match them in terms of their characteristics there. Okay, so that's what a matched participants design is. Now, compared to the other two designs, matched participants design does sound good because it's like, yeah, we're reducing the individual participant differences, but the issue is that it's actually easier said than done when it comes to matching participants. Okay, it's easy for me to say, oh yeah, this person's got 120 IQ, let me just go find someone with 118 IQ. That's very easy to say, but actually finding that person in society in general is quite difficult. Okay, and we have to make sure that they are similar to the other person in other aspects too sometimes. Okay, so it's quite time consuming and it can be quite costly. Sometimes companies or researchers recruit and they have to actually pay companies to do this for them because it's not easy and they don't have access to so many people that they can just select whoever they want. Okay. Also, another issue is if this participant decides, okay, I don't want to be in the study, I'm out, the other person automatically has to leave as well. Their results kind of become useless. Okay, that's what futile means. Futile means that the other participants' results automatically become invalid or useless, so they have to leave as well. And you can see how that might lead to a very time-consuming process if multiple participants decide to drop out. Okay. The advantage, although, is similar to repeated measures, you've got lower individual participant differences there. Okay, so that's the match participants design. And then conclusions and generalizations. I think you guys have covered conclusions from lower level sciences as well. We'll watch a small video about what conclusions are as well. A conclusion is just a decision or a statement that you need to write about what the results we obtained from research mean. We have done conclusions in the practical assessments we've done this semester, as well as, you know, when you did bio or physics last semester, you would have definitely done some form of conclusion there. Okay, a conclusion is always written after the results have been obtained or results have been found. You can't write a conclusion before. You can write a hypothesis before, but you can't write the conclusion before because the conclusion is always based on the results. If you don't have your results, how are you going to write your conclusion? Okay. Now, when you're writing a conclusion, and this is probably more so in psychology, when we write a conclusion, sometimes we ask you guys to also talk about whether this conclusion was influenced by other variables. If that's the case, you just bring up all those unwanted variables we talked about previously. Okay. Now, depending on the conclusion that's made, a generalization can be made as well. Generalization is very similar to a conclusion, but now we're just talking about, can we generalize or apply these results that we have to the broader population? Usually we can do this, but it really depends on other factors as well. If we have too many unwanted variables, sometimes this might actually reduce the reliability of the study. And so in that case, we might not be able to make a generalization. Also, whenever we use convenient sampling, we cannot make a generalization because not everyone in the population had an equal chance of being selected. So convenient sampling, too many unwanted variables means you cannot generalize your results. That's like almost a hard and fast rule there. Okay, I'm going to show you guys the video about conclusions. APA reporting conventions, don't stress too much about this. We will be doing our research scenario assessment. It's not really a poster as such, but it's just like you'll get a research scenario and you'll get a bunch of questions that are similar to the kind of questions you get in practical assessments, like what is the aim, what is the hypothesis, what is the IV/DV, all that kind of stuff. But it's not going to be in the form of a poster, so you don't need to stress too much about the poster template and all that stuff. And you don't need to worry too much about the APA reporting conventions, but remembering that if you do plan to do VCE Psych, this is something that you will have to think about. And you will be doing a poster when you do VCE Psych. Okay, so that's basically the end of it. You don't need to know this either, so don't stress about these two slides too much. Okay, I'm going to show you guys the video. So what I'll do is I'll pause the recording or stop the recording here.